This video is a supplement to the discussion of psychrometric chart in lecture 2 of topic 4. This psychrometric chart is in SI system. There is another one in American engineering system in the lecture note as well. The horizontal axis is temperature in degrees Celsius, ranging from -10 to 55. This chart is at atmospheric pressure and useful in reading parameters on ambient air. So for ambient air, 55 degrees Celsius is kind of an upper limit and there was no need for higher temperatures. There are a number of curves here. These sets of curves that you see, and there is a percent written on them, these are relative humidity curves. There are some sets of lines as well that we need to know. One of them are these lines, as you see, parallel to each other. These are humid volume lines. These lines that you see, these are wet bulb lines that we are going to come to discuss them next. There are a number of other curves and lines that are out of the scope of this lecture and may be discussed in thermodynamics or energy balance courses. You have already looked at relative humidity equation in the lecture note. W stands for water because we have water vapor as well as dry air. So the second part of the mixture is dry air. If you know the relative humidity, for example, like 50%, and you know the temperature of the ambient air, let's assume 30 degrees Celsius, we can locate a point on this chart. So here at 30 degrees Celsius, I can go and pick the relative humidity of 50% and locate a point. If you go across horizontally, I will hit the vertical axis, and the vertical axis is called absolute humidity, where the moisture content is given in mass, kilogram of water per kilogram of dry air. This is absolute humidity, and the equation is here. Relative humidity that we saw before and absolute humidity that we have here are related to partial pressure of water in the air mixture and the total pressure of the system. The equation that we saw before, relative humidity is related to partial pressure as well as vapor pressure, which is a function of temperature. So if we know the temperature, vapor pressure is known. Either from relative humidity or absolute humidity, we can get the partial pressure of water in the air and we can quantify it. Actually, that partial pressure is what determines these values in mass of water per mass of dry air. These are molecular weights. This is the molecular weight of water. This is the molecular weight of air. The absolute humidity for 30 degrees Celsius and 50% relative humidity is 0.0132 kilogram of water per kilogram of dry air. You learn about dew point in the lecture note. It says dew point is the temperature at which the mixture would be saturated. It means that if I again assume that ambient air at 30 degrees Celsius and 50% relative humidity, and if this is my point, in order to know what is the dew point of this air, I can just go across until I hit the 100% relative humidity line or the last curve that I see, and then I can come down and read a temperature here. So the dew point of air at 30 degrees Celsius and 50% relative humidity would be about 18 degrees Celsius. If I cool down this air to 18 degrees Celsius, I cannot cool it more before condensation occurs. This is actually how we get rain, because rain is a mixture of vapor when it hits a cold front. That's how condensation occurs as rain. Next is wet bulb and dry bulb temperatures. If I measure the temperature of air with a thermometer, the reading would be called dry bulb temperature. That you see here. So the numbers on this axis are all dry bulb temperatures. If I put a wick, a wet wick around the bulb, and then I let the air blow over it, I will read a lower temperature. So the temperature reading will not be the same as before. That temperature is called wet bulb temperature, because the bulb is wet at that case. When you go to swimming pool and then come out of the swimming pool, you feel a chill on your body. That chill is actually wet bulb temperature that you feel, which is cooler than if your body was dry. In order to get the wet bulb temperature on humidity chart, I can locate the point. Suppose I want wet bulb temperature of the air at 30 degrees Celsius dry bulb temperature and 50% relative humidity. So locate the point, and then from there I go parallel to these wet bulb lines that you see. So I go parallel until I intersect the last curve, 100% relative humidity, and then I can read 22 degrees there. So you see this is 20, this is 25, so that is 22. That is exactly opposite to 22 here as well. So if you come down from there, you can see 22 degrees on the horizontal axis as well. Next is humid volume. Humid volume is defined as cubic feet of humid air per mass of dry air. So here, look at humid volume, meter cube of humid air, ambient air, per kilogram of dry air. So again, let's locate the point. I want to see the humid volume of air at 30 degrees Celsius and 50% relative humidity. That is my point. This time I draw a line parallel to these humid volume lines. So how do I get the value? I know that this is 0.85, and I know this line is 0.90. So the humid volume, assume it's x, is somewhere between. As you see, the distance b is 0.85 minus x. Distance a is 0.90 minus 0.85. So I have distance a and distance b. I can measure it with my ruler and then use these distances and the numbers 0.90 and 0.85 in order to get the value of x by interpolation that we have seen before. If you want to just have a guess, I would guess that humid volume that we have is somewhere 0.878 meter cube per kilogram of dry air. This is just a rough estimate, not exact, as I can get it from interpolation.